All right. Welcome to equation solving, modeling, and then some finance math. Ooh, sounds like this is going to be a fun one. So, our goal is to basically solve exponential, logistic, and logarithmic equations algebraically. Okay, so from this point forward, we are not allowed to use our calculators and graphing to help us solve it. We're still allowed to use our calculators, we just can't graph in our calculators to solve stuff. So, ultimately, a lot of what we're doing involves these properties right here, these one-to-one properties. It says that if I have b raised to a power, and that equals the same b raised to a different number, well then those two exponents have to be equal. Same thing happens with log. If I have log of u equals log of v, then u and v have to be equal to each other. And these are called the one-to-one properties. So we use these a lot of the times, but we also will just occasionally just switch back and forth. So if I have y equals b to the x, I'll just switch forms and say that this is log base b of y equals x. So as long as I know how to switch back and forth, I probably will never get stuck. All right? So let's jump into some examples. If you feel like you're good, you can pretty much skip to the last part where I just go over some basic formulas. All right, so example one. What I really want to do here is try to get this x by itself first. So I'm going to try to get the entire exponent by itself. So I'll start off by doing that. By just dividing both sides by 20, and I get 1/2 x to the third equals 1/4. And now, it'd be really nice if I could write the base of this exponent in terms of 2, because then I could write this 1/4 in terms of 2. So I could do that by using a negative exponent. And I can do the same thing on the other side. I can say that's really a 2 to the negative 2. Because remember that this is 1/4 is really a 1/2 squared, and I can rewrite that with a negative exponent, and it will pull it up to the top. So now that I have 2 raised to a power equals 2 to a power, I can just set those powers equal to each other. Okay? And then I just multiply. Boom. Done. Math. That wasn't so bad, was it? In 2, I think what we want to do is just switch forms. So let's just switch this into exponential form. This says 10 to the second power equals x squared. Okay, so that's 100 equals x squared. So x is going to equal plus or minus 10. And then we always need to check our answers when we're dealing with x's and logs. And because this is being squared, I'm allowed to have the negative in there because it will turn it positive. So I can keep both of these answers. If that wasn't squared up there, like for example, this was 2 log x equals 2, which would give us a similar answer, that one would not work with a negative 10 because it would violate the domain of the log. So you always got to just double check what you're starting off with here. All right, you ready for the heavy hitters? Whew. First thing I'm going to do with this one is just multiply everything by 2 to get rid of that fraction. So I'll end up with e to the x plus 2 equals 8. E to the negative x, why don't I just rewrite that as e to the x in the denominator. And now, I don't really like having x in the denominator, so I'm going to multiply everything by this e to the x. So I'm going to get e to the x squared, which power of power lets me just multiply them, plus 2 e to the x equals 8. And this looks an awful lot like a quadratic to me. So I'm going to set this equal to 0. For your sake, I'm going to let u equal x squared, although I personally would try to recommend that you get used to not bothering writing u unless you really have to. But that's okay. We're still learning. So you get u plus 4 and u minus 2. So u is going to equal negative 4 and u is going to equal 2. And here's the thing, no one really cares what u equals. We want to know what e to the x equals. So I have to resubstitute. So I get e to the x equals negative 4, and I get e to the x equals 2. And for this one, I can actually stop. Exponentials can't equal negative numbers. It's not possible. And for the e to the x equals 2, I'm just going to switch forms. So I'm going to get ln of 2 equals x. And that's going to be my final answer. Woo! We're cruising. All right, over here, let's think here. I'm just going to first actually condense this left side, I think. So I'm going to have ln of 3x minus 2 times x minus 1. So remember, addition means multiplication. And then over here, I think I'm just going to move that 2 up as an exponent. So now I have a log equals a log, so the inside of those logs have to be the same. So I'll just FOIL this out. So I get 3x squared, and then minus 3x minus 2x, that's going to be a minus 5x, and then plus 2, and that's going to equal x squared. Okay, so let's just think about this a little bit more. Gotta simplify. Let's think here. 2x squared minus 5x plus 2 equals 0. So I'm trying to multiply to 2 and add to a negative 5. All right. So I think that's going to be a negative 4 and a negative 1. So I'll factor by grouping. Look at that. That worked out really nicely. Factor out a 2x, get x minus 2. Factor out that negative, I get an x minus 2. So I'm left with 2x minus 1 and x minus 2. So x is going to equal 1/2, and then x is going to equal 2. And since I'm dealing with logs, I need to just quickly check my answers, okay? So in order to check my answers, I'm just going to make sure that this 1/2 and the 2 don't make the inside of one of these logs negative. So 1/2, if I plug in 1/2 right here, or right here, I get negative numbers, which means that this will not work. If I let x equal 2 over here, I'll get, let's think, this is 6 minus 2, that's positive, and 2 minus 1, that's positive, and over here I get 2, that's positive, so this answer is going to work. Boom, math. This is so much fun, isn't it? Oh man, we only got 2 more examples to go. I hope you're thrilled and super excited. Woo. All right. Now we're starting to get tricky. So here we have log 3 of something equals log 9 of something. If I could get these to be the same base, then I could use that one-to-one property. So what I want to try to do is rewrite this log 9 in terms of a log 3, or vice versa. I could try to write the log 3 in terms of the log 9, but I think it's a little bit easier actually for us to rewrite this side. And so what I'm going to use is the change of base. So I'm going to say log 3 of x over log 3 of 9. So that's just the change of base formula, which says that I can do log of the, I was going to say of the top, but that's not the right thing. It's log of that x over log of the base. And I can rewrite it with any old base that I really want here, okay? And over here I'm just leaving this alone for now. That's an x, doesn't look like it, that made it worse. All right, so let's think, what is log 3 of 9? Log 3 of 9 is actually a 2. So this is actually a 1/2 log 3 of x on this side. And we still have that log 3 of x minus 6 over here. So from here, I'm just going to simplify some stuff, I think, first. So I'm just going to make that a 1/2 over there. And then, cool, I can just set the insides equal to each other. Remember that x to the 1/2 is really a square root. So I think we can just square both sides. So I'll get x squared minus 12x plus 36 equals x. If I just keep simplifying, I'll get x squared, what is this, minus 13x plus 36 equals 0. Okay, and that's going to be, what, minus 9 and minus 4 will work nicely. So I'll get x equals 9 and x equals 4. And I just got to do a quick double check, right? Make sure that they work. If I plug in 9, I get positive numbers. If I plug in 4, I get a negative number in that first log. So that one doesn't work. Only x equals 9 is going to be a solution. Whew. That was fun, right? This was the tricky step right here, was turning this into the 1/2. Okay, if you can figure that part out, then you're good. We're going to do the exact same property over here. Okay, so I'm going to say this is log 2 of x plus 1 minus a log base 2 of x over a log base 2 of 4. That's going to equal 1. This log 2 of 4, that gives me a 1/2 again, because log 2 of 4 is actually 2, so I have a 2 in the denominator. So let's think here. I can just combine this left-hand side. Log 2 of x plus 1 over, let's see, I have to do this first, right? The 1/2 x, but that's really a square root of x. From here, I think I'll just switch forms, right? I'm kind of stuck. My x's are all trapped inside the log, so I'll just switch. 2 to the first equals x plus 1 over the square root of x. cross multiply, so I'll get 2 square roots of x equal x plus 1. Oh boy, I'm running out of room here. Let's think. I'm going to have to cheat and just move to a next page. Jump into a new page. 2 square roots of x equal, what was that? X plus 1, x plus 1. Let's square both sides. That's going to give me 4x equals x squared plus 2x plus 1. Whew. This is fun, isn't it? So I got x equals 1, and then I just need to really quickly check to make sure that it works. If I plug 1 into both of those logs, I get a positive number, so that's going to work. Congratulations, we have finished that problem. All right, and that leaves us with these last things. So these are formulas that you need to memorize. You probably had to memorize them last year. We start off with this simple interest. You actually already know this. It's the exact same one we've been using for our population. They are identical, except that now we're talking about money instead of population. So nothing has really changed except the terminology. Here we have compound interest. It's a slightly different formula. P stands for your principal. That's the original amount that you invest. R is the rate. I think most of us figured that out by now. This value of K, sometimes your teachers last year, maybe they would have used the letter N, but K or N, whatever letter you want to use, that's basically how long you're compounding in a year. So it's the number of times compounded. So whether that's monthly, then it would be 12. If it was quarterly, then it would be 4. If it was daily, it'd be 365. And then T is always in years. And then we get this last one down here, PERT. This is for continuous compounded. So it's PE to the RT. I just remember it by saying PERT. And there you go. I'm not going to actually do any examples with these ones because it's pretty much all just the same exact idea of what we've been doing, except that you first have to create the equation and then do some math with it after the fact. All right? So there we have it. Hope you enjoyed this video, and I will see you in class.